12 colleges or units of UP are represented in the panel today. There will be 3 presentations. The first presentation will give us an update on the local scientific studies of rainfall variability in the Philippines, or more generally speaking, water-related hazards. In the second presentation, we shall hear recommendations from our agriculture specialists on mitigation measures to deal with the effects of variability of rainfall and temperature on food crops. These are important to reduce the vulnerability of our food supply to water-related hazards. The third presentation will propose a comprehensive disaster risk management framework appropriate to our local setting and aligned with the new Philippine Disaster Risk Reduction and Management Act of 2010, which was passed just last May. I understand that the implementing rules and regulations are now being drafted. Hopefully, some of the recommendations that will come out of this session today may even find their way into the IRR. While there will be specific recommendations related to flood and drought risk management, I expect some general recommendations too that hopefully may apply to the management of risks and disasters due to other hazards such as earthquakes. We look forward to proposed actions that may be taken at different levels. And even as we advocate community participation in disaster risk management, I believe that we, the University of the Philippines as an academic institution, should be able to define and carry out our role in disaster risk management. The role is primarily to educate and provide salient information for formulating policies and plans, for designing processes and tools that will be useful for other institutions, communities, and individuals. Most fervently, I hope that our efforts to help, being an educational institution, are neither too boring nor too complicated. So, ladies and gentlemen, I am very proud to present to you our panel of experts coming from the various constituent universities of the university, and I look forward to a very lively and meaningful discussion of today's topic. Thank you and good afternoon.
Thank you, President Roman. This afternoon's forum will consist of 3 paper presentations, all falling under the theme, Reducing Risks and Disasters Due to Rainfall Variability, Protecting Life, Food, and Property from Flood and Drought. All 3 papers are products of collaborative efforts of several experts in their respective fields. They will all be introduced to you later in the program. After the presentations, there will be an open forum that will be led by our convener, whom I will introduce to you now. Our convener and moderator is Dr. Benito Pacheco. He is a civil engineer who specializes in disaster risk management. Earlier this year, Dr. Pacheco was named one among UP's 100 outstanding alumni engineers and was also awarded the Outstanding Professional in the field of civil engineering by the Professional Regulatory Commission. He is concurrently professor at the UP Diliman College of Engineering and director of the Institute of Civil Engineering. May I now call on Dr. Benito Pacheco.
Thank you very much, Dr. Mateo. Good afternoon, President Roman, officials of the university, fellow faculty and staff, students, guests, and friends in the other UP campuses who are joining us this afternoon. A very pleasant afternoon to all. The topic this afternoon may not be all pleasant, but the fact that we are all here, I believe, is the message. President Roman, it is my pleasure to introduce the 3 presenters, who in turn will introduce the panel members. We do not have a shortage of experts in the university. We have 20 of them, including one from Pagasa this afternoon, President Roman. And allow me now to introduce the three presenters in turn. Let me begin with the first presenter, Dr. Fernando Siringan. He's a marine geologist and professor at the Marine Science Institute here at UP Diliman. He obtained his PhD from Rice University. His research interests include examining the coastal systems at 2 time scales, the favorite of geologists, the last few centuries, and over the last 10,000 years, with a view towards the protection and conservation of the coastal system. Dr. Siringan, we're very proud to announce, was recently conferred academician of the National Academy of Science and Technology just earlier this month. The next presenter will be Dr. Felino Lansigan, Professor of Statistics at the UP Institute of Statistics in Los Baños. He is also an affiliate professor of the UPLB School of Environmental Science and Management, or CESAM. He is currently a member of the International Scientific Steering Committee of the Global Water System Project of the Earth System Science Partnership. He is also part of the team of the Intergovernmental Panel on Climate Change, which, as you all know, received the 2000 Nobel Peace Prize. Third, last but not least, presenter will be Dr. Guillermo Tabios, a fellow co-professor at the Institute of Civil Engineering here at UP Diliman. He is currently the director of the UP National Hydraulic Research Center. And Dr. Tabios, likewise as Dr. Siringan earlier, was designated academician of the National Academy of Science and Technology earlier this year. Dr. Tabios is recognized for his work on 2-dimensional finite volume hydraulic modeling that had been applied to the flow and sediment transport studies of reservoirs, rivers, and lakes all over the Philippines, including phenomena of dam break and lake salinity transport studies. Without much further ado, it is my honor to call on the first presenter this afternoon, Dr. Ando Siringan.
Salamat, Ben. Magandang hapon po sa inyong lahat. Good afternoon. I'm the assigned presenter for this topic on rainfall variability. Our team leader is Laura David of UPMSI. And with us are Toti Moya of IESM here in UP Diliman as well. And Flavi Hilario of Pagasa. If I can have the first slide, which will show the headline of the Philippine Daily Inquirer a few days ago. It had for its major story the water crisis that still grips Metro Manila. This water crisis is due to a drought that started in the second half of 2009 and persisted until the middle of this year. But just September of last year, Luzon was deluged by rains delivered by Ondoy and Pepeng. The drought this year and the floods last year resulted from 2 very contrasting levels of rainfall, with a threat that the variability of rainfall will become even greater than what we are experiencing now because of climate change. Global climate models are relied upon as an initial step to design adaptation strategies for the coming years. But how appropriate are these models for the Philippines? The 2 panels shown are examples of projections 70 to 90 years into the future for the A1B scenario of future greenhouse gas emissions. In the A1B scenario, emissions are still growing much faster than what the modelers think is required to stabilize the global temperature rise. In this global models of the IPCC, only 4 pixels depict the Philippines. These models cannot capture the lateral variability of rainfall in the country, which is represented by the colors in this modified Corona's climate classification map. And the map shows 4 climate types. We would like to have models that reflect this lateral variability. It is good that efforts are underway. Pagasa undertook a downscaling process, reducing the 300-kilometer resolution global model to a 25-kilometer resolution localized model. And shown here is the result of their downscaled model for average percentage rainfall change by 2050 under the A1B scenario. In this model, Mindanao is projected to have a decrease in annual rainfall, while the rest of the country is projected to have a net increase. These downscaled models are driven by global models, and thus local drivers of precipitation are not considered. The downscaled models appear to reflect lateral variability of rainfall, but cannot capture events such as droughts and typhoons. When a typhoon passes through the country, it usually brings a lot of rainfall. Shown is the daily rainfall record from Pagasa's Science Garden Station in Quezon City, and the high precipitation events are mostly related to typhoons. Note that there is much variability in the amount of rainfall per typhoon. In the figure, we can also surmise that typhoons contribute a considerable amount to the total rainfall. Thus, interannual variability of rainfall is due in part to typhoon variability. The lateral distribution of rainfall during a typhoon is also variable. This is exemplified by the rainfall records from Science Garden and the port area in Manila. Even if they are very close to each other, at less than 11 kilometers apart, and though they are within the same climate type, one can see differences in the magnitude of rainfall events. The 455 millimeter rainfall in Science Garden is the Ondoy event. In the port area, Ondoy delivered only 259 millimeters of rainfall. An Ondoy-like rainfall at 403 millimeters is recorded in the port area in 1970. In Science Garden, in the same event, poured only 277 millimeters of rain. This lateral variability of weather events highlights the need to augment the existing long-term primary weather stations with additional secondary sites placed strategically all over the country. For flood forecasting, the lateral variability of weather events also emphasizes the need to have rain gauges located upstream of population centers, which are vulnerable to flooding. Most of our present stations are in airports or are within population centers. The lateral variability of rainfall also emphasizes the importance of satellite imagery, as they can give us a synoptic view over a large area. Data from NASA's and JAXA's Tropical Rainfall Measuring Mission, or TRMM, satellite give estimates of rainfall intensity. Several hours before a typhoon hits our country, the TRMM estimate, which can be accessed for free through the internet, can be used for advisories of possible downpours. As devastating as floods like Ondoy can be, in general, floods occur in limited space and time. In contrast, droughts can affect broad areas and persist for several months. Let's take the El Nino-related drought this year, for example. In April, below to way below normal rainfall conditions were spread over the country. These are the areas colored light yellow to red in the April situation. In May, rain started to come back at the very south of Mindanao, but drought conditions remain for most of the country, spreading northward, affecting sites all the way to the bigger route. Interannual variability in the Philippines of rainfall in the Philippines is strongly influenced by the El Nino Southern Oscillation Cycle, or ENSO. The graph presents NOAA's ENSO index. Positive ENSO in red is El Nino phase, while a negative index shaded in blue is a La Nina phase. As early as the middle of last year, NOAA, using their multivariate index, predicted a severe El Nino persisting until the middle of this year. There are other factors, though, that can add to the variability of rainfall in the country. There are longer time climate cycles, such as the Pacific Decadal Oscillation,